Good day to you, Algebrites. Today what we're going to be working through is we're going to solve quadratic equations by factoring. Before we can do that, we need to understand two principles. Number one, how to factor. Number two, something called the zero product property. So let's look at factoring and recall the snowflake method, or however method you choose to do this. But here I'm choosing the snowflake method. I put A times C goes on top, B goes on the bottom, and the x's go in the wings. Then from there, I need to determine what two numbers multiply to the 6 but add to the 5, and that's a 2 and 3. So x plus 2, x plus 3 is the factors there. I'll do this one real quick, and then you can pause and see the answers for the other two warm-ups. This one here is an 18 because 3 times 6, and a negative 11, and I'm going to put 3x in the wings this time. Okay, now I find the two numbers that multiply to this, the factors of 18, that add to negative 11. So I see that it's negative 9 and negative 2. Now what I'm going to do is treat each of these as a fraction, and I'm going to divide it or simplify it as if it were a fraction. So here I can divide both of these by 3 to get x and negative 3. So here's one of my factors, x minus 3, and here's the other factor, 3x minus 2. And we are done. The second important thing besides factoring that we need to know is how to use this property called the zero product property. And it states this: let A and B be real numbers. If A times B is 0, then A is 0 or B is 0. Just logically speaking, one or both of them need to be 0 if this is true. So to summarize, if two things multiply to 0, one of those things has to be 0. Maybe two. Well, without even thinking too hard right here, 9 times x is 0, which means x has to be 0 by the zero product property. Same thing there is true for number 7. A has to be 0. Well, what about this here? So it's true that x has to be, or x can be 0. It doesn't have to be, but x might be 0. But what else could be possibly true? Because the other thing that could be 0 is the blue, the other factor. Each factor is set to 0. Each factor can be set to 0. So now when we solve this one, we subtract 2 from both sides. So here are my two solutions. Either x is 0 or negative 2. So let's now practice using the zero product property. Notice all we have to do is we have x plus 2 times x minus 2 equals 0, which means each one of those can be set to be 0. The first one, x plus 2, is 0, or the x minus 2 is 0. Now we just solve each one, subtract 2 from this side. Over here, I'm going to add 2 to both sides. And here are my two solutions. X is negative 2 or x is positive 2. And of course, checking these problems ends up working for us. This one I'm only halfway through. Plug the negative 9 in for both of those a's, and you should end up being true. Just to point out to you that sometimes in math, one will work and one won't work. That actually does happen. Now, it's not going to happen in our contexts this year, but when you get to Algebra 2, you're going to see that. It's called an extraneous solution. So that's why we do check both, because on occasion, mathematically something works, but it doesn't end up working in the end. All right, let's attack number 12. So we already have this in factored form. What do I mean? I have a factor here, 2x minus 1, and another one, x plus 2. They're being multiplied in between, and they equal 0. Because they are being multiplied and equal to 0, the zero product property is true. So that means this one right here can be set to equal 0, and this can be set to equal 0. So 2x minus 1 is equal to 0, or the x plus the 3 is equal to 0. Just like that. Now, unfortunately for many of us, what happens over on this side is we end up getting a fraction. Now I divide both sides by 2, and I get x is 1/2. You can leave it as a fraction. If you convert it to decimal, that won't hurt either. but fraction is going to be the most common form of writing these answers. Over on this side, I just have to subtract 3 from both sides, and those are my two answers, or my two solutions. Is x equals 1/2 or x equals 3? Your turn. Please attack 1314. I'm going to check number 12 with you. I'm going to show you how to do this by hand, which can be tedious with fractions, I understand. But I'm also going to show you that you can really quickly do it with something like Desmos. All right, so first we're going to take the 2x, but this time we're going to substitute in the 1/2 right there. Minus 1. Notice I have a double set of parentheses here, an inside parenthesis within it parenthesis, and that happens on occasion. Some people like to use brackets instead. 3 plus 3 equals 0. Now, it actually never matters what happens over here. Although this is a fraction of some sort, over here, this is going to cancel out to become a 0, and that's nice. 2 divided by 2 is just the 1, and 1 minus 1 is 0. Whatever this is over here, it actually doesn't matter. So taking our time to do that work right there works. You can do that. You end up getting 7/2 there, or 3.5 equals 0, 0 equals 0, and it's a check. But even if you didn't simplify this and you just left it exactly like this, in fact, I'll do that for the second one, just to show you that we don't have to do all that craziness. We just simply need to get a 0. All right, so I'm going to check this for x is 3. Actually, it's going to show up fine here. So 2 times 3 minus 1 times 3. Oops, what's my mistake? Should be a negative 3 is up there. All right, so we did rectify that and put a plus 3 here. Notice that if I hadn't changed that 3 to a negative, because I quickly forgot about the negative right there. If I had kept these as positive, let's just keep that as positive real quick to show you what happens. This here gives me a 5, and this one here gives me a 6. Whoa, snap. 30 does not equal 0. So that means most likely I made a mistake somewhere. Either I made a mistake in my check, or I made a mistake in the actual arithmetic part. So I'm going to go back and check. Oh, yes, the negative. I meant to have a negative. So let me change that up in here, throw some negatives in here, see what happens. Throw a negative there, and change this one to a negative, which means this guy here is now a 0, and this one here is a negative 7. 0 does equal 0, so I am going to change that there. Okay, so we saw that if you are too arrogant and you just say, oh, I'm right, 0 equals 0. Clearly, we can all make mistakes just by throwing a negative somewhere, forgetting a negative, doing fractions, something like that. So let's go all the way through. Number 1 on the next page is asking us to find the roots of the equation. Now let's recall that the roots is synonymous for solutions. Fine, it's synonymous for solutions. So our first step is we're going to factor the standard form of the quadratic. So this is already in standard form, so if it weren't in standard form, I would place it in standard form. So give me a moment here, and over on the side, I'm just going to snowflake. So a times c is 48, b goes on the bottom, and x is in the wings here, or ax in the wings. And the two numbers that multiply to 48 are 4 and 12, and they add to 16. So notice my factors are x plus 4 and x plus 12. So all I've done is taken this trinomial and factored it to two binomials that multiply to this right side is 0. Now we can use the zero product property to split that up. This guy here is going to be set to equal 0, and this binomial here will be set equal to 0. So x más 4 igual 0, x más 12 igual 0, And now we just solve individually these ones. X here is, let me not forget my negatives. Negative 4, subtract 12 from both sides to get negative 12. All right, so when I plug things into Desmos here, and all I need to do is check right there, I get a negative 12 and a negative 4. Done, I've checked it. I've solved this in a separate manner and just double check that my work is true. So always check with graphing, or you can, again, we can plug things in. If I plug a negative 4 in right there, it'll work. If I plug a negative 12 in for both of those, it'll also work. Your turn. Please attack, kill, destroy. Number 2. Go. Now I can do a real quick check here. I can plug this handy thing into my calculator, and in doing so, the negative 4 is squared, plus the 16 times negative 4 plus 48 gives me a 0, and repeat that process with the negative 12 to also get 0. So it turns out that the check is a check. Works well. And we can also check, like we saw earlier, by graphing. All right, that concludes this part right here. Next time, tune in. We're going to take it to the next level with higher, different types of things to factor. Fare thee well.